All right, we're going to talk some more about passing parameters in and returning parameters out of a function. And I will warn you that historically this has caused some confusion. So really pay very, very careful attention, particularly to the return statement. It's very specific. It's relatively straightforward, but some people get caught up here. So please just be really careful for the next few segments to make sure that you understand this concept of return. All right. Let's do an example now where I pass parameters into a function. There's that little x right there, and I return values from the function. Okay, let's see what's going on here. So I've actually written this, I'm going to warn you, in a way that's intentionally confusing because it's going to make a point. All right, so let's look at our function first. Add 5, and it takes as input x. Please take that value of x, add 5 to it, and then return that x back to the user. Okay. All right, so that's just a function standalone. So that x, whoever called me, is going to get a value back, which is the value that was passed in plus 5. Okay, good. So main body of the code, here we go. Z is equal to 4. So now I have z equals to 4. And I say add 5 of z. Now notice, I'm not printing add 5 of z. I'm not assigning it to a variable. I'm not including it in a statement. I am simply calling this function with the value of 4. Now, when you see the parameter being passed in, you have to think not z, but 4. This is sort of like the right-hand side of an assignment operator. On the right-hand side of an assignment operator, we have values. On the left-hand side, we have variables. This is the variable in the definition of the function that is going to be instantiated with the value being passed in, which is not z, but 4. All right. So 4 comes in. X gets instantiated to 4. I add 4 to 5, 9, and I return 9. And what happens to that return? Well, nothing actually, because all I did was call the function, it returned it, and I dropped it. So think about it as somebody throws a ball and you close your eyes and it goes whizzing by you. Nothing happened to it. So while it does officially get returned, nobody caught it. I didn't put it into a variable. I didn't put it into a print statement. I didn't put it into anything. But now ask yourself, what happens when I print z? What is going to come out? Okay. So think about it for a second. There's probably 2 reasonable answers. It's either 4, because that was the value I assigned here, or it's 9 because I added 5 to the value that I passed in. But again, remember, the answer is 4, of course, that I'm not passing z in. I'm passing the value of z. So 4 goes into there. I add 4 to 5. I shove that into x, and I return that parameter. But I'm not if I had written z is equal to that, well, then z would be 9. But that's not what I did. And so, of course, what z remains 4. So no harm, no foul. I may not as well call the function because nothing really happened. All right, now let's look at this. X is equal to add 5 of z. Z, of course, is still 4. We've just established that. So 4 comes in. This x, do not confuse this x, by the way, with this x. We'll get back to that in a little bit. This parameter, which is a local parameter to this function, gets incremented by 5. I return 9. That gets shoved into that x. And now, of course, when I print x, I'm going to get 9. Now, this is really important. This x right here and this x right here are not the same. This could have been y, it could have been a, it could have been any parameter. This is a parameter in the main workspace of Python. Okay, and we're going to be talking a little bit about local and global variables in a little bit. But let me emphasize it here. This parameter, this x, is local to this function. Only these 2 lines of code know about this x. Here, everybody in the main body knows about this x. Okay, so those are different variables. Okay, good. Now, here I took the return of add 5 and I shoved it into a variable, and then I get to use that. I could have also just said add 5 to z. So let's ask the question, what is the value of z here? Well, I initially set it to 4. Add 5 has no impact on z. Of course, printing doesn't have an impact. This doesn't have an impact on z. So z is still 4. 4 comes in, gets incremented by 5, and I return that, and I print. And so now I will, of course, print a 9. Okay, good. So hopefully that was clear. And now I want to emphasize the difference, because everything we've been doing up until now has been using these print statements just so you can see the output, and not for any other reason. Okay? And I just want to really emphasize the difference between this function here that returns something and this function here that prints something. Print is a human function. It sends something back to you, the human, so you can read. Return is for the code. It's for the computer. It's so that we can communicate between function calls and variable assignments and expressions. This is all about the user seeing an answer. This is about, with the return statements, the code itself using values that go into and out of functions. So, okay, let's look again. Single parameter comes in. If x is greater than 0, return 1, else return -1. So it's just returning 1 or -1. And by the way, if it's it's -1 if it's less than or equal to 0. Okay. Print something takes a parameter, and if it's greater than 0, it will print 1 and tell you 1. Otherwise, it will print a -1. Right? It doesn't return anything. It just evaluates, does its thing, and then it's done. This computes something and hands you back the result. So, for example, here I could say, please take the result of return something of 10. 10 comes up here. I return 1. That value becomes 1. I'm going to add that to return something of -8. -8 comes in here. That is not true. I return -1. I add 1 to -1, and I get a 0, and I assign that to x. I'm using these function calls, what gets returned to them, into an arithmetic expression, which then gets shoved into a variable through an assignment. Now, what happens if I say y is equal to print something of 12? Well, let's see. I'm going to call print something. That's fine. There's nothing wrong with this statement. It's just going to call a function. I'm going to come up here, and I'm going to print 1, and you will see 1 on the output. But then it's asking to assign y the result of this, which means it's expecting this to have a return statement, but it doesn't. Y is not going to be set to 1. 1 is not being returned. It's being printed to you. So don't confuse that print statement with that return statement. And so when you print y, it will just say none, which all it means is that the function that you called didn't return anything, and so this is a key word called none. Okay? So be really careful with these. Return is sort of part of the code communication channel. Print is the communication channel between the code and the human user. Okay, good. All right, let's look at a couple more examples. So you may remember this. This is our magic ball code. We have a function called cheap magic 8-ball. We generate a random number between 0 and 4, and then depending on that value, we either print, most likely ask again later, don't count on it, or no. And then here I'm going to call the function. So I call the function. It picks this random number. One of these lines of code in the if, elif, else ladder will print, and that will be it. Right? That print statement, that string, that text will show up on the output, and we are done. Okay? Nothing wrong with this. Perfectly fine code. Let's look at a version of this where I use a return statement instead of a print statement. So same thing. Function definition, pick a random number, if, elif, else ladder. Depending on the value of r, either return, most likely, ask again later, don't count it, or no. And now, look at what I've done. I've just called cheap magic 8-ball, paren, there's a function call. It will come up in here. It will return a value to me. I'm going to take that value and print it. So what was the difference between this and the previous one? The only difference is, where do I do the print? In the previous one, the function does the print. In this one, I call the function and I decide what I want to do with it. Is one better than the other? I don't know. I would argue this one is maybe not better, but it's more flexible. Why? Because in the previous version, the only thing that you can do is take the output of Magic 8-Ball and print it to the screen. That's it. But here, when I return it, I can do different things with it. I can store it into a variable. I can concatenate it with something else. I can write it to a file. I can do lots of other things, or I could just print it. So in some ways, these returns within the function give you more power, because you may not want the function to decide what to do with it. Now, sometimes you may. You may say, look, the function is going to print something. That's its job. Fine, let the function print. But if you want the flexibility of what you want to do with the output, you return values, and then you can use those in any way you want. You can pass them into other functions. You can have them be part of expressions. You can write them to files. So you have more control in this return as opposed to forcing the function to make the decision on what it's going to do with the output for you. All right, let's look at a few more examples. So up until now, we've been passing one parameter in with one parameter out. And I don't think it will surprise you to learn that you can pass more than one parameter in. You've already seen that. But you can also return more than one parameter. So let's see what we got here. We've got a function called return two things. It takes as input two parameters, x, y, comma, delimited. And it computes two values, s, which is the sum, and p is the product. And then if I want to return two things, I simply say return, and then I comma delimit the parameters that I want to return. Okay, super easy. How do I catch them? I catch them in the same way. So here I'm going to call return two things with comma delimited list. Those two parameters are going to get instantiated to 2 and 5. And then paren s comma p, my variable names, is equal to this. S will be the first parameter, p will be the second parameter. And then I can do whatever I want with them. I can print them, I can add them together, I can store them somewhere else, I can pass them to another function, whatever I want. Now, don't confuse these parameters s and p with these parameters s and p. In this particular case, they're the same variable, but they didn't have to be. Remember again that what happens in the body of the function stays in the body of the function. So I could have called these parameters a and b and returned a and b. And again, I'm not returning the variable a and the variable b. I'm returning the value associated with the variable a and the value associated with the variable b. And so out here in return two things, what comes back is 7 and 10, not a and b. And so these parameters and the names of these parameters don't care. They can be whatever I want. These are local parameters to the body of the function. Once the function is done evaluating, those parameters are gone. These outside of function definitions have legs. They continue to have the values as you go down below. All right, one little thing here in the previous, and this is just a style issue. So in the previous one, I defined two variables, either s or p and a and b, and then I returned them. But I didn't really need to do that because it's such a simple calculation. I could have just said return x plus y and x times y, and sort of, first of all, I have fewer lines of code, always nice, conciseness, compactness is nice, and I save a little bit of time not having to define variables that eventually they get thrown away. They're truly, those were irrelevant variables because the only thing that matters are those two values right there that get passed in here. So I could have just as well said this. So notice what I'm doing here. It's sort of like saying print x plus y. That's not a confusing statement. I sum up x and y and I print it. So same thing here. I'm going to sum up x and y and that's going to get returned into s. I'm going to take the product of x and y and that's going to get shoved into that parameter p. Now, return has a very special functionality, and that is that when you hit a return statement, you are done. You are out of that function. Now, everything up until now, that return statement was the last line of the code in the function, which sort of makes sense, because once you hit a return statement, you are gone. You are out of there. No more body to, it's like sort of like a break in a while loop. So in this particular function, I call return two things with 2 and 5. X and Y get instantiated to 2 and 5. I sum them up, I take the product, and I return them, and they get put into S and P. And this line of code is dead code. It will never, ever, ever get evaluated because as soon as I hit that return function, it says, you're out of here. Go home. So there is never any reason, unless these are in conditionals, that you should have a line of code below a return statement. It's bizarre. It makes no sense at all. You can never, ever, ever evaluate that line of code. So I say this to emphasize that return says, get out of here. Your work is done in this function. Send these parameters back, and done. You're out. So it's literally go home. Okay, good. So let me remind you, because we're going to use that fact that return gets you out of there in a second. So this is the code that we had written a few lectures back for computing prime numbers. So let me just remind you. I want to determine if x is a prime number. And so what I'm going to do is I'm going to ask for every number between 2 and 1 minus that number, so in this case 16, I'm going to ask, is this an even divisor? And if it is, then the number's not prime. So while c is less than x, and then you can see I've got a c equals c plus 1 here, and this is the body of the while loop. So let's focus on this, and then we'll come back to this code in a little bit. So if x mod c, so divide x by c and test the remainder. If it is 0, well then that number's not prime. I found an even divisor that is not 1 and it is not 17. And so I say not prime, and I break out of the while loop. And remember that the reason I break out is first of all, for efficiency, once I figure out the number is not prime, I don't have to keep checking. I don't have to keep insisting it's not prime. It's not. We are done. And notice, by the way, here I'm printing because this is just it's not within a function. So I break and I boot out. If this is not true, then I'm going to increment c by 1, and I'm going to keep testing over and over and over and over and over again. And at some point, I will get to the value of 17. This conditional in the while will value to false, and I'm out of the while loop. Now, how do I know whether this ever got evaluated? Well, the way I know is that if I get down here and c is equal to x, well then I must never have hit this, because if I hit this line of code, I would have broken out. And if I had broken out, well then c will not have gotten all the way to the end of the while loop, and therefore I know that the number is prime. That is, I've iterated through all values 2 to 16. This had never evaluated to true. I never hit this print statement. I never hit this break, prematurely exited me out of the while loop, and therefore I can tell it's prime. All right, let's now write a function that does the same thing. And let's see how the return works here. Function is prime, takes a parameter x, 17. Some number is going to come in. Initialize c to 2. I'm going to search all numbers between 2 and x minus 1 and figure out if any of those are a whole number divisor. So same while loop, while c is less than x. Same conditional, if x mod c is equal to 0, return not prime. Okay, so first of all, I'm not printing. I'm returning to the calling function. And the calling function has to decide what to do with it. It has to print it. It has to assign it to a variable. It has to concatenate it to something, whatever it is. That's not my problem. My problem is to tell you whether it's prime or not. Once I hit this return statement, what happens? So let's say I pass in 18. Yep, c is 2. 18 mod 2 is equal to 0. I hit this line of code. What happens next? I'm out. I'm out. Once I hit this, I return back to who called me, and I return them the string not prime, and I'm done. Now, if I don't hit this line of code, I increment c by 1, and I keep going through the while loop, while loop. Now, look at this line of code right here. This is a lone return statement, just hanging out. I'm not checking if c is equal to x. Why is that? How do I know that the number is prime if I get to this line of code? How do I know I cycled through this entire while loop? So remember before, I had to test. I had to say, what is the value of c? Did you get to that last value of the iteration? But here I don't have to do it. Why? Because if I ever found a whole number divisor, if this ever valued to true, will I ever get to this line of code? No. Once I hit this return statement, I'm out of here. So at this point in the code, if I ever exit this while loop, yeah, when I'm done with this while loop and this never gets evaluated, then I know this line of code never got evaluated, and I can tell you it's prime. So you can see the power of the return statement here is that I know at this point, since there is a return up in here, that I never touched that line of code. If I never touch that line of code, the number must be prime. So you can see sort of that elegance, but also emphasizing again, once you hit a return statement, you're out of there. All right, let's do a drill. Please write for me a Python function called countEvens that takes as input a list of numbers. So we're going back to list now, not a list of lists, but just a list of integers, and returns the number of even numbers. Now you got to start paying attention to that word right there. Don't print it. I want you to return it to me, and then you should be able to catch it and print it or do whatever you want with it. I don't care. I think printing the number, the answer would be good. So this function is going to take as input a single list. It's going to calculate the number of even numbers, and then it's going to return that number to me, and then just print that number out to make sure you got the right thing, and of course test this with various lists to make sure you get it right. All right, take a few minutes to do this, please, and then when we come back, I'll show you my solution. Okay, I hope you got that. Let me show you my solution. So let's see here. Here is the call to count evens. So I've just got a list that I've hardwired in here. And notice that I'm going to take the output of count evens, which will be returned to me, and I'm going to just shove it into a variable, and then maybe I will just print that so I can see it. I don't have the print statement here. Count even takes as input a list. I've called it capital L. So this will get instantiated with whatever gets passed in from the calling function. All right, so now I've got to go through the list. So let's think about the algorithm now. I want to go through the list, every element of the list, and ask, is this even? And if it is, add 1 to a counter. Yeah. So I'm going to initialize a counter to 0, and I'm going to say for little l and big L. So big L, of course, is the list. And remember that this is the syntax for little l taking on every value of the list, 1, 2, 3, 4, 5, 6. Yeah, so inside of this for loop, L will be the individual elements of the list. How do I know if it's even? If L mod 2 is equal to 0, then increment the counter by 1. So look at this, be very, very careful with the indentation. This return is outside of the for loop, of course. So we iterate, 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 every time checking to see if it's even, increment the counter if it is, and when we get to the very end, simply return it back to the calling function. By the way, I could have done this for I in range 0 length of list and then just tapped into the ith element there. That would have been perfectly fine. But since I didn't care about the position of the elements of the list, I just went ahead and tapped into the actual elements using this slightly simpler notation. Okay, good. So parameters go in, parameters come out. And again, we're going to keep practicing that because it's a very powerful construct. And again, I want to emphasize why. Because you want functions to have their maximum generalizability. And they are maximally generalizable when they do the calculation and don't decide what to do with the output, but send them back to you, and then you can decide what to do with it. Now, of course, that puts a little bit of a burden on you. The person calling the function has to make some decisions, but that kind of flexibility is really nice because you may want to do different things with a function's output depending on the situation, and you can only do that if things are being returned to you and giving you that type of control. All right, we'll pick it up in a little bit when we come back.